Hello, hello. Hi everyone. Please let me know if I am audible. Am I audible? Okay, okay. We'll just wait for half a minute or 1 minute and then we'll start. Okay, many people are requesting to start from third question. Okay, we can do that also. And the questions were quite easy. We will have a look at all the three. And so, how was your contest? Please let me know in the comments. Got 58.75. Great. Okay, ho. Someone is saying मोटे हो गए हो भाई. हाँ, a little bit. Third was difficult. Okay, just 10 more seconds, then we'll start. Need third question memory limit and stood to 51th rank. Okay, okay, we'll start the video solutions. I'll present my screen first of all. Okay. Is this good to go? We'll start. We'll start with the. So many people are requesting to start with the third question. So we'll start with the third question. Okay. 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 So what does third question say? The name of the question is string counting, and it says that given a string S, you choose some substring S from L to R exactly once and reverse it. For example, in the string geeks, selecting the substring from second to fourth after performing the mentioned operation, the new string will be GKEES. Count the number of unique strings that can be obtained by doing this operation exactly once. Okay, so basically what they are saying is, see, they said that we have a string S, right? And in this string s, we have to select one substring and reverse it. We can do this operation exactly once on any substring. Then how many total different unique strings we can generate by doing this operation? That is the question, right? For example, they said that if we are given geeks and from second character to fourth character, if we select this substring and reverse it, then G will remain as it is. EEK will get reversed, so it will become KEE, and at the end s would remain as it is. So we have got a different string. So in this way, how many unique strings can we generate? Okay, now here there was one simple logic which if you got clicked, you will be able to solve the question, right? You do not need to, like here the we cannot reverse all the possible substring, that is n square, and then out of all the strings generated, select the unique strings, right? That will go in the time complexity of big O of n square, and the length of the string is up till 10 ki power 6, so it will give us time limit exceeded. So we need to think of something better. Now understand one thing, whenever I am reversing a substring, okay, whatever may be the substring, so let us take this is the substring, okay. Suppose at this place it is A and at this place it is B. Suppose I reverse this substring. Will it generate a new unique string? Yes, definitely. Why? Because no matter what things will be here I will get a B and here I will get a which would be different from the original one. You got this point? Whenever we are reversing a substring which has two different ends, we will always get a unique string. Now you may question that even if we reverse a substring which has same ends, they can also generate a new string. Yes, definitely. Let us see that case. Suppose you have G E E K and let us say GEEKS, okay, geeks, okay. Now suppose this is the word. Now you think of reversing this substring whose first character is E and last character is also E. Then if I reverse this, this will remain as it is. This will become EGSKEEKS. Now you will say, okay, I got a different string, but this can also be obtained if we chose not to reverse this substring but reverse only this much part. See, if I reverse only this much part, what I will get? GE will remain as it is. Reverse the four characters which I have selected. So it will become GSKE and this EEKS would remain as it is. These two are similar. So the point which I am trying to make here is whenever we reverse a substring which has different start and end character, we will get a different unique string because those two characters will get reversed. So for example, here it was A, here it was B, now here it became A, and now here it became B. No matter what the characters were in this place, since these two have changed, our string has changed, so we have got a new string. And we can do, if we do not select the strings which have the same start and end positions, then also these things can be done by reversing this I told. So basically if we just count the number of substrings, basically if we just count the number of substrings, count number of substrings such that their start character is not equals to end character, then all these will be unique strings which we can get. So now we just need to count the number of substrings such that their start character is not equal to end character. Now we will think about implementation, but please let me know first, did you understood what the concept should be? Please let me know. Yes, any doubt? So basically, now we need to count the number of substrings such that their start is not equal to n character. We want to do that efficiently. How we can do that? See, for example, suppose I have string A, B, B, B. Then how many different number of substrings I will get such that their start character is not equal to n character? One will be from this A to this B, one will be from this A to this B, and one will be from this A to this B. Then from this A to this B, from this A to this B, and from this A to the first B. And the third would be from this A to this B, this A to second B, and this A to third B. So basically, can I say I will get number of A's into number of B's? I can select one as the starting character and one as the ending character. Here number of A's is 3 and number of B's is 3. So I will get 9 different substrings. Is this clear? Is this clear? Okay. So now, yes, Santosh, exactly. So now we need to count the. So now, how would we would implement this? See, here since they were only A and B, we said number of A into number of B. But in reality, we can have A, B, C up to Z. So what would be the different number of substrings that would be generated? Number of A into number of B plus number of A into number of C plus and so on up till number of A into number of Z plus now we will take B and C, B and D, B and E up to B and Z. So pairwise we will select all the different characters because we need one as the starting character and other as the ending character, right? So if we can do this, then we will be able to solve this. And so basically I can say our answer would be summation I equals to, or let's say character equals to A to Z. Let me tell character P equals to small a to small z, summation character Q equals to P plus 1 up till Z, number of P into number of Q. This would be my answer, and plus 1 for the original string. Yes, so exactly. The concept is if we reverse a substring having different beginning and ending character, we will always get a unique string. So, and this will also cover all the unique strings. As we talked here, if we were reversing the string substring from E to E, we were able to get the same string by reversing the string from E to G. So basically, if we do this, we will get all the answer. Someone is requesting to do all the post contest analysis by me. Okay, let me see. Okay, can you tell me why second summation? So basically we are looping. See, it would be basically for, suppose I take index I equals to 0 means A, I equals to 1 means B, up to index 25 means Z, suppose. Then it would be from I equals to 0 to 25 for j equals to I plus 1 to 25, count of I into count of j. So this would be added in the answer. So this would be done. So that's why I have shown here two summations. Now we'll start with the implementation, right? So what I need to do here is basically, see, first of all, I'll take long answer is equals to 1. Why 1? 1 is the count of the original string, right? Then I'll take count of 26, in which I will store the count of different characters from A to Z. I'll take I and I'll take j. I'll also need to take the length of the string. So I'll take n is equals to s dot size. Okay. Now, first of all, I'll mark all the countings as 0. So, C of I equals to 0, right? Now, for I equals to 0, I is less than n, I plus plus, I'll increment the count of that character. So, count of S of I minus 97 plus plus, right? Now for I equals to 0, I is less than 26, I plus plus. For j equals to I plus 1, j is less than 26, j plus plus. Answer would be equal to answer plus count of I into count of j, right? And I'll return the answer. So let me compile and run it. So now let's submit it. We have solved this problem successfully. Please let me know if you have any doubt. I'll wait for some time and then we'll move on to the first and second question. Can't we generate all the substrings and check if starting and ending characters are different? Yes, we can do that, but that will take a lot of time, right? Even if you use two for loops to just check the starting and ending character of the substring, it will take you n square time, and it will give time limit exceeded. What will be the time complexity here? We have a for loop of size 26, then a for loop of size n, and a for loop of size 26 cross 26, right? So basically our time complexity would be big O of 26 square plus n, which is basically nothing but big O of n, and our length of the string is up to 10 to the power 6. So this will be solved in the given time limits. Okay. Yes. Someone is saying explain once. Okay, I'll go through it once more quickly. See, basically here we need to tell all the different unique strings which can be generated by reversing any of the substring any exactly once, right? Now, so basically we need to tell if we reverse a substring, how many unique strings we can generate. So here if you use one concept, very easy concept, that whenever you reverse a substring having different starting and ending character, it will always generate a unique string. So basically GEEKS. Suppose if I reverse this substring, since the starting and ending character are different, GSKEE, it is a unique string, and it will always be, because suppose I take this as a string, this is A, this is B. If I reverse this, here B will come and here A will come. So no matter about what these characters are, since these two characters have changed, we have got a unique strings. So basically we are counting the number of unique substrings, counting the number of strings which have different starting and ending character. Shreya is asking what does minus 97 means. See, basically when I'm doing count of I, this I should be is an index, so it should be an integer, right? Now, but S of I is not an integer, it is a character. So whenever you use a character in an integer operation, it gets converted into its ASCII value. Okay. and the ASCII value for small a is 97, for small b is 98, for small c is 99, and so on. For small z it's 122. This is 99. Okay, but I want small a at index 0, small b at index 1, and so on, z at index 25. How can I get that? By subtracting 97. If I subtract 97 from them, I'll get the respective indexes. You can also subtract the character a. You can also do like this in case if you do not remember the ASCII value. Is this clear? Could you please explain the second for loop again? Okay. See, basically we want to, count the different substrings having different starting and ending character. So what I'm basically doing is, suppose this is A, B, C, D, E, F, G, and so on. So my I will represent the first for loop, and my J will start from I plus 1. So suppose I is at here, then I'll go through B, C, D, E, F, G, and so on up till Z. So A will be paired up with B, A will be paired up with C, A will be paired up with D, A will be paired up with E, and so on up to Z. Then I will come here, and again it will be paired up with all the characters from C to Z, and so on. Is this okay? Are your doubts clear? Okay, Shreya. Can you explain the multiplication part? See, suppose I have string A, B, B. Then how many different substrings can I get with different starting and ending characters? This A can be paired up with this B. This A can be paired up with this B. So A, B, A, B, B. Then this A can be paired up with this B. So A, B. And this A can be paired up with this B. So A, B, B. So how many different substrings? 4. How can I get that? Count of 2 into count of A into count of B, because I need to fill the starting position and end position. For starting position I have two possibilities of A, and for ending position I have two possibilities of B. So 2 into 2, I'll get 4 different substrings. That's why we are multiplying the all the things. Are there any other approach? See, given the time limits, it would be difficult to think about any other approach, right? The string length is 10 to power 6. So doing it in within the time limits, I don't think, at least at present I am not able to think. If any one of you get any idea, you can definitely tell me. So let's wait for about 10 seconds and then we'll move on to the rest two questions. Okay. Okay, we'll move on to the other questions. So let's move on to beautiful number. We'll start with. Can we do the counting of number of palindrome substring using Maneker algorithm? But that will take it would be a very difficult approach, right? Can you explain deeply? Okay, so I think one or two people have missed it. So let's do one thing first. Finish these two questions as well, and then if there are people after that, I'll again explain the third one. Okay, and these two will not take much time. Also, they are quite small and simple questions. So let's proceed with beautiful number. Given n, check if it is a beautiful number or not. Okay, you will have to follow a process to determine if a number is beautiful or not. Start with the given number guaranteed to be an integer. Replace the number by the sum of the square of its digits. The process continues until the number equals 1, or it loops endlessly in a cycle which does not include 1. Number for which this process ends in 1 are considered beautiful. Okay, so basically what we need to do is we are given a number, anything. For example, what was the example here? It was 19, right? So 19, what we need to do is we need to convert this number into the sum of squares of its digits. So basically this will become how much? 81 plus 1, which would be 82. 9 square is 81, 1 square is 1, so 82. Now this would be converted into 8 square, 64, plus 1 2 square, that is 4, that is 68. Then we need to convert it into 64 plus 36. 8 square is 64, 6 square is 36, so that's 100. Now this would be converted into 1 square plus 0 square plus 0 square, which is nothing but 1. And now this will remain 1 only. So what we basically need to do is, in the input we are given n, and we need to convert it into, we need to keep converting that number into the sum of squares of its digits. And if we get 1, then we need to return true. If we just keep looping endlessly without getting 1, we need to return false. That is basically the question, right? So for this the output is 1, here the output is 0, because if the input is 2, then it will keep looping endlessly. See, from 2 we got 4, from 4 we got 16, from 16 we got 37, from 37 we got 58, from 58 we got 89, from 89 we got 145, from 145 we got 42, from 42 we got 20, and from 20 we got 4. Now we will again come back to the second step, and this cycle will keep repeating, right? And it will never reach 1, right? So what we need to do here, what we can do is we can have a data structure which will hold the numbers which have already occurred. So starting with n, we will first store it here, that n has occurred. Then from here, suppose I reach to n1, after summing the squares of its digits, then I'll mark that n1 has already occurred. Then from here, suppose I go to n2, then I'll say n2 has occurred. We'll keep doing this until we reach 1, or we reach a element which is already present in this data structure. If it is already present, it means that now the cycle will keep looping. So now what we will do, if we get a number which is already present, which we will return a false, and if we get 1 in between, we will return true, right? Now first of all, so this will be the simple implementation, brute force. Okay, but to prove it that it will happen in the given time limit is one thing, right? That it will not, like, suppose we do not get 1 also, and we do not come into a cycle also, it goes on for a very long time, this process, then what? So we need to prove its time limit also, right? So first let's implement it, and then talk about the time limit. Okay, till that time you can also give me ideas how we will estimate the time limit. So basically what I'll do is I'll take an unordered map, which will basically uh, or I can take an unordered set also, which will, in which I will put the different values, right? I'll take int I, and I'll take n1. Okay, now while n is not equals to 1, initially if n is 1, return true. Okay, so if n is equals to 1, simply return true. Now until n is not equal to 1, and dot, sorry, s dot find n is equals to s dot end. So it is also not present in the set. Until that time we will keep doing this procedure, right? So n1 equals to 0. I'll store the sum of squares of the digits of n in n1. So while n is greater than 0, I equals to n modulo 10. n1 equals to n1 plus I square, and n by equals to 10. Okay. Then after coming out from here, what I'll do, I'll take n is equals to n1. Is this much clear? Then if here n is equals to 1, then we will return true, because this while loop broke because n became 1. And else what we will do, we will return false, because the while loop broke because the same element was found in the set. So what I'll do is take uh, I'll insert n, and after here I'll also insert n. Is this clear? Okay. So what mistake I have done? Let me print the value of n every time. So it's not entering in while loop only. If while n is not equal to 1 and acha, okay, so I think I'll keep it here, and now let me run it. So I've got yes, and if I submit it, so I have solved this problem successfully. Now we'll discuss about the, so I hope you got what was the mistake. I was inserting the initial value of n here, and then I was checking if it is not present, how it can be possible. I only inserted it, right? So I need to insert that after checking. Before checking, if I insert and then check, it will always be false, right? So that was the issue. Now we'll discuss the time complexity. So can anyone tell me how can we decide that this will always happen in the given time limit? Anyone? See, let me explain you why this will always happen and it will not go out of time limits. See, basically the constraints on n are what? It is between 1 and the value of n is between 1 and 10 ki power 9, right? So the minimum value of n is 1 at any given point of time, and the maximum value of n is what? 10 ki power 9. So it's basically 1 followed by 9 zeros. So how many places are here? It is only one digit. How many digits are here? It is 10 digits. At every step we find the sum of squares of digits, right? Now what can be the minimum and maximum value of sum of squares of digits depending upon the n value? The minimum value can be 1 if the number is 1. What can be the maximum value? The maximum value of sum of squares of digits will be when there are 9 nines. And what would be the square of digits, sum of square of this digits? It would be 9 square into 9, because each 9 would be squared and added 9 times. So sorry, each 9 is first squared and then all the 9 nines are added. What would be this value? 729. So basically, after the first step, our number will always lie between 1 and 729. So in the worst case also, the while loop cannot have more than 729 loops, because it will find one or the other element in the set already present, because the sum of squares can lie only between this. In actual reality, the sum of the loop will be very much less than 729, but this is in general I am talking. In the worst case it would be 729, right? In reality it will always be very much less, because from here you got to 729. Now from 729 you'll go to where? 7 square is 49, 2 square is 4, 9 square is 81. 81 and 49, it's basically 80 plus 50, that's 130. 130 and 4 is 134. Can you see? From this we went to 729, from this we went to 134. Now this, from this we will go to a even smaller number. 16 plus 9, 25 plus 1, 26. So what I'm trying to say is it will be very less, but just to give the proof of time limit, it would take at max 720 loops. Is this also clear? We'll wait for around 10-15 seconds and then we'll move on to the second question. Hello. Is this clear? Okay, now we'll move on to the second question. And then for people who came late and want to understand third question, please wait. I'll discuss once more. Okay. Strong students in school. This was a very simple question. Please explain the last question. You explained very well. Thank you, Sagar. So one guy is asking, please explain the last question. So I've already explained it initially, and there were some people who joined lately. So don't worry. This is the last question left. After this, I'll again explain the third question once. Okay. So let us go through this quickly. This is a very simple question. In a peculiar school, students are admitted based on their strength. The strength of n students is given to you in the form of an array ARR. The PT teacher wants to analyze two sets of m students. Help him find the maximum possible difference between the sum of strengths of students in the two groups. One student can be a part of more than one group. Basically, what they are trying to say is, in a school they have n students and their strengths are represented using an array. Okay, let's say 2, 4, 9, 1, 6, 3, 7. Okay, now there is a number m given which will always be less than equal to n. The teacher wants to find two subsets of m students such that the difference between the strengths of this set and this set is maximum. So what do we mean by strength of a set? The sum of strength of all the students. So summation of strength in the first set and summation of strength in the second set, and this difference should be maximum. That is what they are trying to say. Very simple question. What we can do? Suppose m is equals to 4. In one set, we can take the 4 strongest people, and in the other set we can take 4 weakest people, so the difference would be maximum. So what I'll need to do is, first of all I'll short this, so it will become 1 2 3 4 6 7 9. Is this okay? Okay, now I'll take these 4 in one set and I'll take these 4 in another set, it is said that students can be, one student can be a part of more than one set. What is the sum of the strength of first set? 4 plus 3 7 plus 2 9 plus 1 10, and here 4 plus 6 10, 10 and 9 19, and 7 is 26. What is the difference? 16. This is the maximum we can achieve. So basically we need to short the two arrays, short the strength array. In one set we need to take the first m elements which are the weakest or the lowest valued. In the second set we need to take the m biggest values and then find the difference and return it. Very easy, I'll implement it. By that time, if you have any doubt, please let me know in the comments. So int s1 equals to 0, s2 equals to 0. I'll take I and j also. First of all, I'll sort the array. So array comma array plus n, I have sorted this. Now for I equals to 0, I is less than m, I plus plus, s1 is equals to s1 plus array of I. These are the m weakest people. For I equals to n minus 1, I is greater than or equal to n minus m, I minus minus. S2 is equals to S2 plus array of I. These are the m strongest people. Now return S2 minus S1. That's it. Let us compile and run it. So we have got the expected output. Let us submit it. We have solved this problem. What would be the time complexity? It would be n log n because we are sorting the array. Okay. And what would be the space complexity? Constant space. We are not taking any new array or something. So the auxiliary space would be constant. Someone is asking, can we do it in O of n? Okay, then we need to think about count short. What are the values of the strength? The value of strength is up till 10 ki power 5. So we can use count short to sort the array, which will take big O of n time, and then find the for m smallest and m largest elements. In this way, we can do it in big O of n time also. Is this much clear? Please let me know if you have any doubts. Otherwise, for some people who joined lately, I'll discuss the third question once more so that their doubt is also solved. Okay, welcome, Neet. I'll wait for 10-15 seconds more. If you have any doubt, please let me know. Otherwise, I'll start with the third question again. So Siddharth is asking, can we solve third problem by, finding the number of palindromic substrings and then subtracting them from the total number of substrings? Okay, we need to think about that, but we need to efficiently calculate the number of palindromes also, right? And our approach is also kind of same. If you see basically what we are doing is we are saying that the first and the last element do not match. So it's basically, it should not be a palindrome. If the first and the last character do not match, it will not be a palindrome, and when we reverse it, it will generate a unique string, right? So if we can find the number of palindromic substrings in big O of n, then we can definitely do it. So any doubts in first or second question? So are those people here who want me to discuss the third question as well? Please let me know, then I'll discuss it again. You got memory limit error, maybe because you might be taking 10 ki power 6 cross 10 ki power 6. You need that much size. Okay, Litesh is saying let's discuss. Okay. Okay, so I'll again discuss the third question. Okay, so I'll discuss the third question once more and then I'll take the doubts regarding this. So, what does it say? Basically, see, I hope you people have read and understood the question. It basically says that we are given a string and we need to perform one operation. What is that operation? The operation is select any substring and reverse it. We need to perform this operation exactly once. Then by doing this operation exactly once, now we can do it on any substring. There are various substrings, right? So how many different unique strings can I generate by doing this operation? That is the question, right? And it says that it's so basically, if we understand, see, the length of the string is 10 to power 6, so we can't you know take each substring into consideration, then reverse it, then put that generated string in a set, and then at the end return the size of this set, which basically has all the unique strings, because it will give time limit exceeded. So the one thing which we need to understand is that if we reverse a substring in which the first and the last character are different, it will always generate a unique string. See, for example, this is a string. Here I have A. Okay, suppose here I have P, 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 and P, and here I have B. If I generate this substring, then here I'll get B, here again 6 times P, and here A. So even though all this remained the same, because the starting and ending characters were different, B came here and A came here, and so I got a unique string. So the idea is, whenever we reverse a substring having different starting and ending characters, we will always get a unique string, and it will also cover all the cases. Now, you might also ask that, okay, we can also generate a unique string by reversing a substring which has same starting and ending character. Yes, I agree. A, B, C, D, B, E, K. Suppose I reverse this substring, that is A, B, D, C, B, E, K. I got a unique string, absolutely. But this can also be done by reversing C and D only. I do not need to take these two into consideration. If I reverse C and D only, I will get A, B, D, C, B, E, K, which is same as this. So what I'm trying to tell, if we reverse a substring having different and starting and ending character, it will generate a new string. And if we calculate all such substrings having different starting and ending character, it will cover all the different cases. So now basically I need to find the number of substrings which have different starting and ending character. So how can I do that? See, I want to fill two places. Suppose I have 1, 2, 3, and 4. I want to fill two places. How many different numbers I can generate? Here I have four choices, and here I have four choices. So I'll get 16 different numbers. But if I ask you, I want to generate a two-digit number such that its starting and ending character is different. So here I have four possibilities, and here I have three possibilities, because the one which I took here cannot be repeated here. So I'll get 12 different numbers. Similarly, I want to count the number of substrings having different starting and ending character. How can I do that? I want to fill the starting character, I want to fill the ending character. Here I'll see how many different possibilities I have. Suppose in my string I have 17 unique characters, but I also need to take their count. So for example, AABB, how many substrings are there with different starting and ending character? See, this A can be matched with this B, this A can be matched with this B. So AAB and AABB, I have two, and this A can be matched with this string, this B, and this A could also be matched with this B. So AB and ABB. So I have four different. How? I did it by multiplying number of A into number of B, which is 2 into 2, which is 4. Basically, in starting position, I said I would take A, and in ending position, I'll take B. For A, I have two different indices. For B, I have two different indices. Right? So how can we calculate now the total different substrings having different starting and ending character? We can loop from I equals to 0 to 25, where 0 index represents A, 1 index represents B, and 25th index represents Z. And I can loop from j equals to I plus 1 to 25, and in the answer I can add answer equals to answer plus count of I into count of j. Basically, count of 0 will represent the number of indices where A is there in the string. Did you got this point? So answer equals to answer plus count of I into count of j. So I'll get all the substrings having different starting and ending point, right? So that is what I have done here exactly. You can see I have taken a counter variable of size 26, initially marked all of them with 0. Then I have calculated the character count. So for I equals to 0 to n, where n is the length of the string, count of s of I minus 97 plus plus. Then I have made two for loops and made all different possible values of different starting and ending indices and added it to answer. One more thing, I need to initialize answer with 1. Why? Because the I also need to count the initial string. So overall, I'll get the answer and I'll return it. The time complexity will be big O of n, because these two for loops will run. This first for loop will run for 26, second will run for n, third will run for 26 into 26. So basically, n is the biggest in general. So I can say time complexity is big O of n plus 26 square, which is big O of n. Please let me know you understood this or not. Litesh, are you there? Did you understood? Any doubt? And the other people, Manoj is present. Manoj, did you understood it? Any doubt? Please let me know. Clear? Okay. Okay, Litesh, you are welcome. Glad you understood. Okay. Thank you very much. There are 25 people in the stream. Please like the stream if you have already not liked it. Okay, so we'll wait for a minute and then we'll end this stream if all the doubts are cleared. Okay, we'll end this live stream here. Thank you so much for joining, and I hope you people got all your doubts cleared. Okay, thank you. Good night. Take care.